Repair in advance. 4 AA batteries. Okay. Got it. Safety glasses kit and plastic tray. Forget. Battery holder. Battery hodo. Bottle nozzle.
Bottle nozzle?
Yep, bottle nozzle. One of these.
Oh.
See, aren't you glad I done that?
Yeah.
Got the gloves. Got the crocodile wire.
Yep. Yeah.
Pin opener.
Pin opener?
Yeah, it's the paper clip that they've unfolded. It's actually in there somewhere.
Paper clip?
It should be in the kid's glove.
So there wasn't one in the kit, so...
What?
No. Huh. Unless it's in those little, things like in a cigarette butt.
Could be. It's showing it's in here too. Yeah, in that one video, I seen that guy, it had fallen out of the box when he opened something up. Wait.
Yeah, right here.
Tin 2 chloride. Got 10 and then 2 Roman numerals in
Yeah, 10
parentheses.
2 chloride dihydrate.
Okay. Got everything all together?
Yep.
What's that third bottle you got there?
Liquid soap.
Oh, that's for the...
Yeah, to spread it out.
Oh, okay.
Remember?
That's right. The hedgehog is inside the little test tube thing.
Yeah.
Alright. Pour 1 bottle of... Let's see. Remove the cap from the tin chloride. Pour 1 bottle of sodium hydrogen sulfate into the bottle of chloride. Should have a red label and a green label.
Yeah.
Next time I have to remember to bring a paper clip over.
Okay.
Alright, insert your nozzle. Use the red cap and shake the piss out of it. 20 to 30 seconds. Timer goes off when you're done. What the hell did you say, lady? Done. Alright. Now pour the whole bottle into your petri dish. Put your clips on after you do that.
First, we need to put on 2 drops of liquid soap. the soap. Those on so that the terminals are touching the liquid. And now we put on our battery pack.
Mind the polarity. That's what it says right there. How do I use batteries? Watch the dendrite grow. You don't have to turn the battery back on or anything?
Not that I see, there's no switch.
Okay. Just zoom in with your camera.
Okay, where's there we go. Max zoom. I'm on max zoom. Let's see, where are you again? Ah, there you are.
I think it'd be better if there was a dark surface under there.
Dark surface.
Underneath your petri dish. Got anything thin and dark? She said, I don't know.
Not that I don't know.
There should be a box around here somewhere.
What's going down in here now? So probably needs more wood in it. When you stick that light in your ear and it comes out on the side, that you know there's trouble.
Yeah, I know. You know my brain done fell out.
Look at that go.
Yeah.
Finally. Yeah.
Yeah.
Yeah, that. See? That's it, alright. Just our luck. Got dead batteries out of Dad's truck. As soon as I hook up my 9 volt, it starts a growing.
Looks like a crack going out across there, don't it?
Yeah. It does. Yeah.
Jesus, damn it, I can't see.
I think that's what's growing.
Yeah.
Okay,
Take a close-up look.
that's little bits of tin. Isn't that neat?
Yeah.
This looks like a crack going out across there, though. Well, now you know that,
Hey, can you please put that back on there?
what?
Yeah, on there.
On where?
On the stuff.
What?
Wow, look right around the terminal there.
Mm-hmm.
Ain't that interesting?
Well, now you know that the side with the ring on it is the negative side.
Yeah. You mean the side with the hexagon?
Yeah.
The female end?
Rate the experiment. What do you give it? 1 to 5 stars.
Probably 5.
That finally worked.
Yeah.
Okay. Check this out. You got more stuff here. Scientific description.
Batteries are basically electron pumps. They suck electrons in with their positive side and pump them out with their negative side. I thought it was vice versa. When such a pump is connected via electric hoses, i.e. wires, a variety of chemical reactions can take place. By the negative electrode, some particles will capture the electrons that are pouring out, and by the positive electrode, some particles will give their electrons away. In our experiment, the ions tin 2 plus, i.e. tin atoms with 2 electrons missing, will gladly accept some electrons at the negative wire and will turn into metallic tin. Meanwhile, the positive electrode itself, which is made of iron, will give some of its electrons to the positive wire, leaving some ions floating around. This is why the red crocodile clip will eventually dissolve if you don't disconnect it. Why does tin dendrite grow? By attaching the crocodile clips to the petri dish edges, we connect the tin chloride solution to the batteries. Once connected, the electric current starts to flow through the solution. Near one of the clips, a tin reduction takes place. Tin solution. Okay. Tin is a metal that precipitates, forms a solid as a solid elemental tin. The tin dendrite grows in the direction that the electric current flows through the solution, from one clip towards the other. More details. The crocodile clips are electrical conductors known as electrodes. A variety of types of electrode is available. It is important to learn about different types that have been invented and to understand the type we use in our experiment. Electrodes may be made of metal, graphite, or polymer material. Some of them participate in chemical reactions that occur in a solution called consumable electrodes. Others are chemically inert, non-consumable electrodes. Tin forms on one of the clips as a dendrite that grows directly towards the other clip. Why does the dendrite not appear as a sort of tin island near the first clip? The answer is that once a bit of tin dendrite has grown on the electrode, it can also conduct electricity. Consequently, it acts as part of the electrode immersed in the solution. And so, each new branch of dendrite grows further into the solution. It is important to understand that dendrites made from different metal solutions grow in diverse ways because each metal forms unique crystals with unique properties. Tin has a very special crystalline structure and forms long and thin but strong enough crystals. What is electrolysis?
Electrolysis. Electrolysis.
Electrolysis is a process by which chemical reactions are induced by an electric current. Electrolysis takes place when current flows through a solution or a fusion of certain substances known as electrolytes. Electrolytes are substances that can split readily into ions in a solution. For example, ammonia chloride forms two ions in an aqueous solution. Electrolysis provides us with a way to form new substances which evolve from substances presented in solution under the influence of an electric current. Such products can also be formed by secondary electrode reactions. For example, oxidation of tin chloride to tin gives oxygen, which evolves as a gas from water during electrolysis. What is electric current? It is a flow of charged particles. These particles are electrons, or ions. As the electric current flows through the wires, it sets up a negative charge on one of the electrodes, or clips, and a positive charge on the other. This makes the ions in the solution move between the clips. The positively charged electrode is called the anode, and the negatively charged particles move towards this clip. The negatively charged electrode is called the cathode, and the positively charged particles, or cations, move towards this electrode. This is how ionic current forms in solution. So basically that's doing the same thing as what's happening inside the battery. So basically you got two batteries here. Just about. I guess you could say that. Although I hope you don't intend to hook this up to nothing and get electric current out of it without that. Because that just won't work. In our experiment, tin deposits on the cathode and grows into a beautiful dendrite. More reactions occur at the anode. The main process is the formation of oxygen. At the same time, a secondary reaction between the evolving oxygen and tin chloride takes place. You should note that the oxygen which reacts with the tin is not actually an O2 molecule. It is more like atomic oxygen, a very reactive particle that participates in this reaction. It oxidizes tin to tin. A white precipitate of tin oxide forms. These are not at all the reactions that occur near the anode. These are not all the reactions that occur near the anode, but there is no point making our story more complicated, so let's skip them. We have chosen tin chloride because of some specific properties of tin. Firstly, tin crystals form thin and long structures. This is because the speed of crystal growth in one direction is faster than the speed of crystal growth in other directions. Secondly, tin is a bright, glittery silver color, which is why the dendrite looks spectacular. Tin is also a ductile and soft metal, which decreases the chances that the dendrite will break owing to its own weight or detachment from the clip. In fact, the dendrite floats on the surface of the liquid. Moreover, metallic tin is inert enough to oxygen and moisture from the air, so it will not decompose during the experiment. Finally, the tin reduction reaction is fast enough to be able to watch the dendrite grow. Can dendrites be obtained from other salt solutions? Tin is the best for this experiment. Many metals form a precipitate as electric current flows through a solution of their salts, but only tin provides such a spectacular dendrite. Some metals, such as lead, would flake off the clip surface layer by layer. Other metals, such as copper or silver, would form weak, porous structures that would collapse under their own weight. Each metal has unique characteristics, which results in different crystalline lattices and consequently crystals with unique properties.
Is it going to keep it growing and look like that thing?
No, that's a tin hedgehog. That's what it's supposed to look like.